So let us go ahead and see the demonstration of services. This is our current scenario. We have a Kubernetes master, only one master with the name k8s master, and one worker k8s-worker1. Now what we'll do is we'll add one more node in the cluster and we'll see the changes in the cluster. So after this first command, we'll add additional node to this cluster and the name of the node would be worker2. Now after you create the node, follow this documentation that is there in the resources section. You have to install Docker runtime on the worker node. Follow all these steps from here. You have to install kubeadm, kubelet, and kubectl on the new worker node, and then you'll have to set up AC Linux, and they'll install kubeadm, kubelet, and kubectl, and change the Kubernetes conf file. Once that is done, you'll have to add the node. Now the new node would not be using the same kubeadm joined command because I had created the cluster long back and the token of the cluster is gone. So the first thing that you have to do is you'll have to create a new token using kubeadm token create command. So after you run this command, this token would be created and you'll have to use this token to add the new worker node in this particular kubeadm cluster. Now this is the worker node. I have used the token in the kubeadm join command. This is the IP address of the master node followed by the port number 6443. And as I said, I have used the token that has just been created. And the discovery token CA certificate hash is same as previous, which was used in the previous command. Typically what you should do is that you should save the kubeadm join command because the hash certificate will be needed later on. So once this is done, this node must have been added to the cluster. This is my master node. Let us see kubectl get nodes, and now if you see we have one more nodes, worker1 and worker2. See the age of the nodes. k8s master and k8s worker1 is 2 days old and k8s worker2 is only 4 minutes old. So this is how you add a new node in the Kubernetes cluster if you are using kubeadm. Of course, we'll be using cloud service providers like AWS and Google Cloud. In that case, all these things are not necessary. But if you're doing it yourself, make sure to run this kubeadm token create command on the master node and use this token in the kubeadm join command, which you might have saved after you ran the kubeadm init command. So both the clusters have been created. Let us see the changes in the cluster. There's nothing actually. These are the three nodes that we have: k8s master, k8s worker1, and k8s worker2. You can see that it has been created 60 minutes back. I took a little bit of break in between. Anyway, it does not matter. So let us proceed with our demo. Now what I'll do is I will create a namespace prod, and I'll use this namespace for all the objects that we are going to create. I'm not using any manifest file. I'm just using the kubectl create namespace command. Now I have an additional namespace which is prod here, and I'll create all the objects in this particular namespace. The first thing that I want to create is using 7.7 HTTP web page deployment bracket service. So let me tell you what I'm doing here. I'm using this Docker file to create a very basic HTTP web page which is already there in my Docker hub. And if you want to create a pod, this is the pod manifest file, but we are using this deployment file. API version is apps v1, kind is deployment. In the metadata we have Kubernetes service deployment, labels is env training, and chapter is services. And the selector I'm using match expressions rather than match labels. Just for a little bit of change, I want to make sure that use both match labels and match expressions. It will be helpful. So the first expression says that the chapter should be in either services or namespaces. And the second match expression says that the value of the section should be 7. And this will be used to select the pods. And here we have the pod template. The name of the pod should be k8s service pod. And we have 3 labels: env training, chapter services, and section 7. And in the spec, of course, we have containers. So this is the pod template. I'll use this particular manifest file to create the deployment. So this is the file, http web page pod service. Actually, this is not the file. I need to create the deployment. So this is the file 7.7 http web page deployment underscore service.yml. I'll be using this file to create the deployment. This is the command to create the deployment, which you already know, but notice the namespace. I have mentioned -n and then prod. Press enter and it is giving some error. So let us troubleshoot. It is saying that error when creating this YAML, of course. Deployment in version v1 cannot be handled as a deployment v1.deployment.spec.deployment template. So it is saying that in the deployment specification, then in the deployment template, and in the pod template specification, or an object metadata, name, labels, it is unable to read because it expects a colon but found 7. So meaning that this template metadata, this is the pod template, it will not work because I have mentioned numeric 7. So let's change it to 7, and then we'll have to change the selector also. Here it will be. So let us go ahead and see. Let us create this, and the deployment has been created. Let us go ahead and take a look. kubectl get all, namespace would be prod, and we should have one deployment. This is the deployment. Then this deployment has created this replica set, and then we have 6 pods. But what I want to know is that where all the pods have been created. Okay, so the pods have been created in both the nodes. 3 pods are in worker node 1 and 3 pods are in worker node 2. Perfect. This is what I wanted because we'll be using NodePort. Okay, now we'll be creating service. We'll be using the manifest file to create service. Okay, so this is the manifest file. API version is v1. Let me increase the font. Okay, API version is v1. Kind is service. Metadata k8s service. Label env k8s training. So let's change it to training because that's what we had mentioned. And app, let's say http app. Okay, in the specification we are mentioning that the type of service would be NodePort, and the target port is 80, port is 8080, and node port is 32500. In the selector it will be the pod selector. I'll mention chapter to be services section 7 and env training. So these are the selectors of the pod. I did one mistake while creating the deployment. I did not mention port 80 in the container. So I'll go ahead and delete the deployment and create it one more time. Now one more thing here is that if you see, I'm not using the name of the deployment. I'm typing kubectl delete -f followed by the file name. So this is another neat way of doing stuff. You do not have to remember the delete command. Just mention the file name. Whatever objects have been created, which is mentioned in the file, all those objects will be deleted. So it is gone now. If I do kubectl get all wide, so it is done. So what I'll do now is I'll change the deployment and I will add port for the container here, port 80, and let us go ahead and create the deployment again. So let's go ahead and troubleshoot the error. It says that the port field is invalid. Sorry, it should be container port, I guess. Container port 80. So let us try to create this again, and okay, again it was a syntactical error. Let us go ahead and change it. It should be ports here because there can be multiple ports in the container, and then it's an array. Include the container port. It should work now, and the deployment has been created. Kubectl get all. If you do kubectl get all, see the deployment has been created. We have this deployment, we have this replica set. I hope everything is fine. All the containers are running perfectly fine. So let us go ahead and create the service. So this is the service, and the API version is v1. Kind is service. Metadata is the name of the service. Then labels is the labels of the service. In the specification, we mention the service specification. The type is NodePort, and these are multiple ports. We have target port, which is nothing but the port of the container, which you have seen to be 80, and port on the service is 8080, and node port is 32500. Let us go ahead and create the service. Okay, so kubectl create f and the service. Make sure to mention the namespace. It's saying the YAML mapping values are not allowed in this context. So let's see what is wrong here. There's some problem with the indentation. Okay, I have fixed the indentation. Now let us go ahead and try to create this service again. So let us go ahead and create the service again. I have changed the name to a 7.8 HTTP web page underscore nodeport service.yml. Press enter. Sorry, it's not delete, it should be create. So now the service has been created and it should be in the prod namespace. Let us go ahead and try to see that. kubectl get service prod, and this is where you see K8 service nodeport. The type is nodeport. It has given a cluster IP and the external IP is none. Now in the port section, 8080 is the service port and 32500 is the node port. When you use kubectl get service command, it does not show you the container port. The port mapping is only from service to node. So the left hand side is the service port and the right hand side is the node port. Now how do you access it? So there are two ways. We'll get the external IP from Google Cloud Console or EC2 console, or if you know the public IP of your server or Google Compute Engine instance or an AWS EC2 instance, use the public IP. So that's why the external IP is none here. But we have something called cluster IP as well. Now, the cluster IP, as I said earlier, is used to talk to the service within the cluster. So you cannot use cluster IP to communicate with the service from external clients or browser. So let's see, I will use the cluster IP and the service port, not the node port. Now this is not cluster IP service type. I'll show that next. But here the cluster IP means that this, if you are accessing the service from other applications that are within the cluster, then you can use the cluster IP also. You do not have to use external IP. So nodeport gives twofold service types, the nodeport itself and the cluster IP also. You can access the service or the application from external world and from internal cluster also. So if I do a curl and it is showing me the same HTTP web page, which we'll see when we use the external IP address. Remember that this YAML to JSON error is very typical of an YAML indentation problem or a YAML error. So whenever you get that error, make sure to double check the indentation in the YAML file. So let me show you again. What I'll do is I'll try to create one more service with another name. So instead of create a service nodeport, I'll just name it as test. But what I'll do is I'll intentionally make sure that indentation is incorrect. And now if I go ahead and try to create this service using the createF command, so it will show you that the error is converting YAML to JSON. Now remember this, that whenever you get this error, it is typical of an YAML indentation error or any YAML syntactical error. This is the external IP address of one of the worker nodes. Let us see which worker node. And this is worker node 1. So if you see, I'm using worker node 1's external IP, which is similar to public IP in AWS and public IP for your on-premise server also. Let us go ahead and try to access it internally. So it is giving you some output. Hello, I'm a container inside of a Kubernetes pod. This is the same application that I had used. Let us use the other IP address also, and it is giving you the same output. Let's see from the browser whether it works or not. So first I'll use this IP address and port number 32500. It should give me this output. There you go. Let's use the other IP address also. Again, this is the public IP address and it should give me the same output. So I'm using two different node ports. If I keep on refreshing, I'm getting the same output. So the service of type nodeport worked. So this is what we did. We created a deployment with 6 pods and we created a nodeport service type and we accessed the application from internet and internally. So that's how nodeport service works. Let us go ahead and see the second type of services, which is cluster IP.